it comes to resource optimization, we usually think about it in a way of either like scaling up pods, so like horizontal pod auto scaling, for example, aka adding more pods, or for even vertical pod auto scaling, so adding more resources like CPU and memory to an existing pod. Now the other piece of it is the cluster auto scaling. Okay, so adding more worker nodes or decreasing the number of worker nodes. But what about if we think about it in a serverless type of approach? So when we're thinking about serverless, we write code that is triggered based on a certain event. So a trigger occurs, then the code runs. It's, high level of how or why you would use serverless. But do we have anything like that in Kubernetes? And the answer is yes, with KEDA, K-E-D-A. Now with KEDA, you can have event-driven auto-scaling, okay? So an event occurs, KEDA kicks off and does what it needs to do with the pods. When we're thinking about this, we want to think about it like serverless. Again, there's an event that occurs, trigger happens, that trigger just so happens to be in Kubernetes for our environments for pods. And with KEDA, we've been able to install it in various environments for a long time, but now Azure actually has the ability to enable it as an add-on. So what I want to do is I want to take a quick look at that. All right, so there are a couple of different ways. Number one, in the portal, we click on the portal here, and if you just type KEDA and you go to auto scaling, okay, you can enable KEDA right here. I'm not going to do it because I want to do it through the terminal. And one other thing that I want to show here. If you're not already familiar with KEDA, highly recommend just checking out the website, KEDA.sh. As you can see, you get a pretty good explanation right here, right? And I actually like this explanation the best. So, KEDA works alongside standard Kubernetes components like HPA, so it's not removing the need for horizontal pod auto scaling and can extend the functionality without overwriting or duplicating. So again, it's based on event-driven scaling, right? So let's head over to VS Code here really quick. So like we just saw, we can do it in the portal, or we can do it by enabling the add-on. So you can either create a new AKS cluster and enable the add-on, or we can do it with an existing cluster. So let's go ahead and do that. I'm actually just going to change, because that's where my AKS environment is. I'm going to go ahead and I'm going to run the AZ AKS update command. All right, and it's going to go through and it's going to enable KEDA. We'll go ahead and give that a few minutes. All right, and that's been enabled. So let's head over to the web browser and do a quick refresh. All right, and as we can see, we now have KEDA enabled. And then if we click create, we can go through and we can set up these workloads here, okay? So this is going to be based on, let's see, name, namespace, target workload. This is the workload that will scale on your selected trigger, okay? So you're of course going to choose one. Let's see, if we go to default, I don't have anything running, so we probably can't really see much here. Yeah, we actually don't have anything deployed, so we won't see that there. But let's actually go through and just deploy something really quick. Let me head back over to VS Code, and we'll just deploy, I don't know, an Nginx container, or an Nginx pod rather. All right, I'm just going to copy this. This is just an Nginx deployment. Oh, let's actually make sure we are connected. All right, beautiful. kubectl, get pods, watch. All right, cool. Everything is running. Let's head back over to the web browser. Let's just refresh. Click create. Yep, okay, cool. Now our workload comes up, so we'll just call it test, right? So polling interval. It's the interval at which KEDA checks your trigger source, all right? Every 30 seconds. Cooldown period is the amount of time that KEDA waits for the last trigger. Minimum replicas. So this is interesting. KEDA has something called, I forget what it's called, zero deployment, zero pod, something like that. But if your workload isn't running anything or doing anything, it can actually scale it down to 0 to save resources. Maximum replicas, we can keep it on 100. And then we have this trigger type. So Azure Service Bus, CPU, cron, memory. Okay, that's interesting. So maybe we change it to like CPU. And scaled object has CPU trigger, but the container doesn't have the CPU request. Okay, so I don't have CPU requests and limits set up. That's fine. So we can actually just maybe memory. I'm gonna get the same message. Yeah. Okay. So let's head back over to cron, and we could just keep all this basic just to get an idea of what it looks like. And then we click next. We could also customize with YAML. What does that mean? Ah, okay, cool. So this is just the same KEDA object that you would use if you weren't using the add-on, right? Cool. Let's go ahead and click save and create. And then now we have our enablement right here. So autoscaler events, any warnings that may occur, and boom, that's how we can set up KEDA implementation if you don't want to do it with standard KEDA and you want to just use the add-on.